Today I'll be talking about problem 9 on the exam. The problem had to do with a particle being shot into a magnetic field and finding out what the radius was given its mass and charge. So to start, we look at the force on the particle, which we know is equal to ma because it's circular motion, and we know that that is equal to mv squared over r from physics 140. So then we equate that to qvb, which is the force due to the magnetic field. So this implies that mv over r equals qb, and so now we want to find v. Well, we can find v based on the potential energy from our electric field over here. We know that the voltage times Q is the total energy gained from traveling through the electric field. So we can set 1/2 mv squared equal to voltage times Q. We solve this to find that velocity equals the square root of 2 times the voltage times Q over m. We then can plug this into this equation right here, and we can find that m over r times the square root of twice the voltage times Q over m equals Q times B. If we solve this for r, we get this nice equation right here, which basically tells us that r is directly proportional to the square root of m over q. And since we know that m2 equals m1 over 3 and q2 equals twice, that's supposed to be q1, sorry, we can say that r2 will be equal to 1 over the square root of 6 times r1. We can say this because if we plug in m over 3 for m, and we plug in 2q for q, we can pull out 1 over root 6 from that equation. And that tells us that we simply multiply the given value of r1 by 1 over square root of 6, and it should give us our answer, which I believe is C. And that's how you do the problem.